We're looking at the perceptual learning application for hypothesis testing module 10A. For this perceptual learning activity, we're going to be evaluating information and deciding whether or not the null hypothesis distribution is believable. When we have a high p-value, a high probability, then we would consider the null hypothesis distribution to be believable. That says that the sample mean could easily occur given our assumption that the null hypothesis distribution is true. In this case, however, our p-value is really small. It's 0.005. And given that it's smaller than our alpha level of 0.05, we are going to decide that the null hypothesis distribution is not believable. Okay, now we're being shown the null hypothesis distribution. We're being given the p-value, it's 0.205. We're also shown the sample mean. When we're looking at the null hypothesis distribution, it's predicting that the sample mean is going to end up within approximately plus or minus 2 standard errors. If you recall the empirical rule, 68% of the values are within 1 standard error, 95% are approximately within 2 standard deviations. When we want to get technical, which we do for a z-test, that's going to mean plus or minus 1.96 standard errors. So our sample mean is right in the middle where the null hypothesis distribution said that it should be. So good job to the null hypothesis distribution. We retain the null. Here we see a p-value that again indicates a very believable null hypothesis distribution. The sample mean could occur with that scenario slightly more than 50% of the time, so we retain it. We click on this card on the right. Now we're being shown a null hypothesis distribution where the sample mean is not in the middle where we would expect it to be based upon this null hypothesis distribution, but instead it's far away. It's out in the tails. And when we look at the p-value, the p-value is less than or equal to our alpha level of 0.05, so it's saying, yeah, not particularly believable. And along the x-axis, we can see that the estimated z-test value, if we were to calculate the z-test, would be around like 2.3, right? It's between the 2 and the 3, about a 2.3, and that is greater than our 1.96 standard error cutoff. So remember, 95% of the sample means, if the null hypothesis is true, will be between that negative 1.96 and that positive 1.96. We would consider them representative of that particular null hypothesis distribution. We have a sample mean that's outside of that. So we say this null hypothesis distribution isn't particularly believable, and we'll reject the null hypothesis represented by a h sub 0, and we'll support the alternative hypothesis represented here by an h sub 1. Okay, for a p-value of 0.12, we'll go ahead and retain the null because that's greater than our alpha level. I know 0.12 isn't particularly really strong that the null hypothesis should be believable, but we're just saying, hey, as long as it's greater than 0.05, we'll believe the null hypothesis distribution. So here's a case where the null hypothesis distribution is very believable. Right, our p-value 0.705, that says good things about the null hypothesis distribution. The sample mean is fairly close to the middle where a null hypothesis distribution says it should be. And if we look at what the z-test would be approximately, well, it's between this 0 and negative 1. It's probably a little bit less than negative 0.5. Certainly it's not negative 1.96 or greater. So we retain the null. It's a good null hypothesis distribution. Likewise, in this scenario, we're going to retain the null hypothesis distribution. We got a good solid p-value. It's bigger than 0.05. Our sample mean is here in the middle. The z-test is almost 1, but it's definitely not positive 1.96 or greater. So based on any one of those 3 criteria, we would know that it's worth retaining this null hypothesis distribution. Those 3 criteria are the sample mean is close to where the null hypothesis distribution says it should be, our p-value is bigger than 0.05, and our z-test, if it were to be shown here, would be a little bit less than 1 and not beyond our cutoff of 1.96. So we retain it. Okay, now here we have a null hypothesis distribution that's not particularly believable. Why? Because all that we require the p-value to be is 0.05. I should actually say all we believe the p-value should be is a little bit bigger than 0.05, and we'll believe the null hypothesis distribution. This, however, was less than or equal to our alpha level 0.05. So that says not believable. Low probability of the null hypothesis distribution creating the sample mean. And the sample mean is out here on the edge. And if we were to look at the z-test, it'd be around probably like a 2.2-ish or so. And that's greater than 1.96. So we have three different reasons, again, to reject this null hypothesis. So here we go, reject. And again, we'll reject it, same reason. Reject it again. It's a low p-value. It's saying it's not very believable. The sample mean is far away from where the null hypothesis says it should be. And if we look at the estimated z-test, that z-test would be around like a negative 2.33, definitely beyond our negative 1.96. So here we're only given the p-value. This p-value says that the null hypothesis distribution is pretty believable. It's we would only have rejected it if it had been 0.05 or less, so we retain. So here we reject. It's just the null hypothesis distribution is just not a good fit for that sample mean. It's not good helping us to predict. You know, imagine that you were going to hire someone for the job or hire someone to make predictions for you. If they're making good predictions, you retain them. If they're not making good rejections, you fire them and get someone else, right? You're like, well, you know, 0.175 is a little bit out there, but good enough, we'll keep you. 0.23, good enough, we'll keep you. 0.87, oh, this is looking good. You know, you said this is where the sample mean should be right here in the middle, and look, it was. We're keeping you, right? 0.175, hey, it's better than, you know, 0.05, we'll keep you, right? Now, for this person, we'd be like, I'm sorry, you said the sample mean should be here in the middle based upon this null hypothesis distribution. Look, it was much further out than we thought. The p-value was really, really small. The z-test was more than negative 1.96 in terms of it being beyond that. So reject. 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 And reject again. Retain. We'll go ahead and reject it again. Look at this. This null hypothesis distribution could not have done a better job. So why would we want to reject it? Right? We're like, we tell the research hypothesis, we don't need you. Because look, the null hypothesis distribution is doing such a fantastic job. All right. So once you go through those 30 practice trials, it'll tell you how you did. In this case, we're going at a nice slow rate. And we were going so slow that sometimes the correct answer was given for us. So our percentage correct was 56.67. It needed to be 80% in order to pass. So I'll click continue and just give it another go. This time I'll go really fast and see if you can keep up with me and what your thoughts would be as I do this. So we have rejected. Of course, I clicked the wrong one there. Reject, reject, retain, reject, retain, reject, 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 retain, retain, reject, 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 retain, reject, reject, retain, reject, retain, reject, retain, and look at that. 96.67%, decision time 1.24 seconds per decision. All right, so when we click next, they'll go ahead and let us know that our completion code is 918. Now that completion code is specific to this particular quiz attempt. And so if you were to attempt it again later on, or if your fellow student was attempting it, each time we'll have a different completion code. So you take that completion code, for example, it's 918, and you put it in as your answer to the quiz, and that way you'll get full credit for it. All right, take care.